Hi, and welcome back to Geology. So this is number 2 of the 2-part series of igneous rocks. So earlier we went through and we kind of talked about some of the structures in which igneous rocks can be formed in or solidified in. So you might remember even from when we were creating our geodes with our minerals and how we heated up the water and we saturated it with the borax and then put the eggshell in, and then voila, the next day we had crystals. Metamorphic rocks can kind of run, igneous rocks can kind of run on that same process, is that we are definitely going to need heat and pressure in order for different minerals to form and then combine to create igneous rocks. And so that's what we're going to be kind of talking about today. So you might remember previously from the last thing we talked about in our last conversation is the idea of Bowen's reaction series, which is just the idea that certain minerals are going to form at different pressures. So you might remember that we talked about the idea of some minerals forming really deep or creating really deep in the Earth's crust, or found or mined, however you want to think about it. And that's because some of them need certain types of temperatures and pressures to crystally structure or create themselves, if you want to think about it that way, is that they need a certain type of environment to be formed in. And so igneous rocks can have certain minerals that are in their combination to be formed there. And that's what Bowen's reaction series is forming at. So it's just different minerals have different melting points. And so some lava is also going to have certain type of mineral rich elements in there, while others may not. And so we'll talk quite a bit about, so even when we get to the volcano section, we'll talk about the idea that we have certain types of volcanic flow due to certain minerals. So for example, Hawaii is a great example, is that it constantly erupts. No one is scared to go to Hawaii. Most people are pretty excited to go there to visit, but no one goes in fear that the volcano is going to blow up and they're not going to return. It's a naturally flowing volcano that erupts all the time, and it just doesn't have a whole lot of viscosity to it. It means that it runs really, really smoothly and that it doesn't have a whole bunch of sticky, heavy elements in it. So it kind of just keeps flowing. So it has a lot of SiO4, silica in it, where it kind of makes the lava a little bit more runny. Whereas if you were to go to Mount St. Helens or Pompeii, where Vesuvius is, those are volcanoes that are extremely explosive. So they have a lot of carbon in their lava, and we'll talk about the difference there. Today, though, we're going to mostly discuss just the idea of how to identify igneous rocks, and then we'll look at some examples of them when you guys get to class. So first off, igneous rocks can be classified into 2 different groups: intrusive and extrusive. And so we talked about those different types of structures intrusively, and so we'll also then get a more feel of what they look like when they are erupted out onto the surface. So intrusive means just that, is that they were formed inside the earth. So they cooled and solidified with magma in either some kind of magma chamber or those batholiths or lacolites or whatever they may be, is that the magma was there, the heat source kind of went away, and as it went away, it formed these big crystal structures of different minerals. So it's not just one mineral, there's going to be several of them there. And so that solidifies, just kind of like our geode did, but on a bigger and a much more grander scale. Normally we say intrusive rocks have phaneritic crystals, and I like to think of that meaning that they are very large. They've fanned out. They're extremely big crystals or structures to them, and we'll look at some examples, especially like if you think about some stones that you might see around your house. Those are normally igneous rocks because they are really strong, they are structurally supportive, they're not going to break. Countertops are a great example. Granite countertops are very popular, and that's because you can put stuff, you can put a hot pot on there or a hot baking sheet, and it's not going to ruin the countertop because that rock is really, really sturdy. It's igneous. The other type of igneous rock is an extrusive igneous rock, which just means that the lava has, or the magma has been extruded and kind of the earth has let it out or spit it out, if you want to kind of think about that, and it's then become magma, and then it cools and solidifies as well. And normally it does this pretty quickly. So because it's super hot magma and then it cools and you get aphanetic, which is just smaller crystal structures. So normally intrusive has really, really big crystal rock structures to it, and extrusive do not. They have much smaller. And then sometimes they don't have any at all because it just cools so quickly that the crystal structure or the minerals that are in there are not even able to crystallize. So as we go through, with igneous rocks, once again, we'll first look and say, okay, is it intrusive or extrusive? And then we're going to look at the grain size or the crystal structure that is there to help figure out what type of rock we're possibly looking at. So remember, we're kind of detectives trying to figure out what we're looking at here. So sometimes we can have, and you can read these right here, coarse grained igneous rocks, which just mean that they have super large crystals, and you can see those structures or those mineral chunks in them. And that's going to be something of a granite. So once again, that countertop, it's very, very popular right now. My friends always get really annoyed with me because I'll sit and look at their countertops and be like, this is muscovite mica, this is a ruby, and they're like, oh my gosh. But these are things that you hopefully will be able to look at and see at some point as well as we get more familiar with these rocks. Once you get from very coarse grain, intrusive, we can jump down to still intrusive, but much more of a finer grain, means that it cooled a little bit faster. So intrusive and composed of smaller minerals that cannot sometimes be seen. And we'll look at examples of this, but one is a rhyolite. There's also a rock called diorite that I think looks like a Dalmatian that is very similar to this fine grain. Then we can have example, these are our two extrusive grain sizes, porphyritic and pyroclastic. Porphyritic just means that it almost had like a two-part cooling system, is that it started to cool more than likely intrusively, and then was spit out extrusively and then cooled differently. So granite can also be an example of this, and we'll also talk about some other ones that are very similar that you can see like have big crystals in it, and then it's encased in something that just kind of looks like almost cement almost. And then finally, our pyroclastic ones, which are really interesting to look at. This is going to be our obsidian or our pumice, which you've probably seen. I know I've put out obsidian and showed it to you guys, but we'll also look at the pumice as well, which you've probably seen as well before too. You might even use it in the shower. It's kind of one of those loofahs that will take off your dead skin. Pumice is used for that. So these are normally violent, extrusive, in igneous rocks that are erupted out very violently. Obsidian is beautiful. It's called volcanic glass. It's emitted very quickly out into the environment. The lava cools almost instantaneously and it forms volcanic glass. And that's sometimes referred to as obsidian as well. So when we're looking at igneous rocks, we're also going to look at the composition, which we're going to be kind of looking at. I like to think of these three terms, felsic, intermediate, and mafic, as colors to help us figure out what elements are present in that igneous rock. I always like to think felsic is fair, intermediate is medium, is mafic is dark. So those are kind of my three little tricks to the trade. Felsic almost seems like fair, and mafic I always think of like the mafia who wears black. So go with that if you want, but that's how I kind of think of it. And intermediate clearly is in the middle. So felsic minerals form from magma that contains large portions of silica. And remember, silica is probably the most common element in the Earth's crust. And so these are going to be very light colored elements, and we're going to start looking at the composition of these. I always think that these are very, once again, almost like whites and pinks, maybe even some purples in there. So it contains a lot of potassium feldspar. I wrote K feldspar here, but K stands for potassium on the periodic table, and quartz, which we saw in our mineral box, which once again, don't be fooled, because quartz can be clear, it can be yellow, it can be blue, but for the most part, I always say felsic rocks, if you run it underwater and then look at it, it should almost look like there's almost like ice in there. That's your quartz. And we'll talk about, I'll give you some clues on potassium feldspar. Normally has like a pinkish color to it. Intermediate rocks kind of contain both light color and dark. So you're going to have a mixture of the potassium feldspar. You're also going to have a lot of hornblende. You might remember our olivine. Those are sometimes in there. Our biotite mica. We saw the muscovite mica in our mineral box, which is a clear color, and its sister mineral is biotite mica. Same idea, very, very thin, but it's just a black color. And then finally our mafic rocks, which are going to be, once again, really dark in color because the silica is not there. These normally form pretty deep below in the Earth's crust. I also think that too. If you think about mafic, normally form way deep in the Earth crust. Intermediate is closer, and felsic is going to be our most closest to the surface. And once again, these are going to contain dark minerals such as plagioclase. We do have some feldspar in there sometimes, and pyroxene. And olivine, that's another one that we looked at too. So very, very dark colored. So to kind of give you a look at igneous rocks as a graph, as you can see, these are all different minerals. We've got quartz, potassium feldspar, plagioclase, biotite mica, this guy, hornblende, pyroxene, and olivine. So very light colored, very, very dark, heavy colored. And what happens is that we can look at what type of magma is there. We've got felsic, intermediate, and mafic. And when we see these types of elements, these are the types of igneous rocks we're going to be looking at. And I have great examples of basalt and gabbro. I do have one of peridot, which is beautiful. It's almost a green color, which I really like. For those of you who know me, I love green. And then finally, we're also looking at then our felsic, our rhyolite and granite. And then it even breaks it down in aphanetic and phenetic. So remember, aphanetic is very low crystal, not very coarse grain, whereas our phaneritic is going to be large crystals because they cooled and were able to fan out. So we've got granite, diorite, and gabbro. So once again, I have examples of these. So if we're looking at something that has a lot of quartz, potassium, and feldspar, and you can kind of see that percent by volume, and the lighter colors are going to be over here in our silica. So we're going to get used to looking at this chart and hopefully help figure out some information. So once again, this is just a real quick review of our intrusive rock structures. We have batholiths and stocks, which are just almost kind of large, cooled tubes that run magma up and then form in these huge, huge chambers. So I like to call like our batholith is like this big bathtub of magma that the system has lost its heat and it cools off quickly, forming igneous rocks. Laccolose are our dome-type mushroom structures, and then sills and dikes. Those are going to be much more of our very stringy, very veiny type of environments that we're looking at. So here's some examples. This was the internal structure of a volcano that the rest of it, this has been all eroded away, and this would have been the cone coming right up. It's called Shipwreck in New Mexico. And then we're gonna kind of fill in some of this information right there. So hopefully this was helpful. We're now gonna look at the actual igneous rocks so that you can kind of get a feel for those phaneritic, aphanetic, mafic, felsic, intermediate type of terms. Bye.